Hi guys, Pete here, N6QW, and this is a Triton Model 540 made by Ten-Tec. That was the analog version, and when I bought this as a Tech Special, had no dial string. The dial string was all goobered up, and the switch mechanism here was out of sync and not clocked. So I thought about adding a digital display to this. And so I bought one of these packaged, it's built by Sanjan, 6-digit counter. They also make an 8-digit one, which is quite nice. So essentially, the way that this works, there's a fixed range VFO operating at 5 megahertz that's mixed with various crystals to put on various bands, and there's no crystal on 20 meters because it's using the IF, the old 5 megahertz, 9 megahertz trick. But on 75 and 40 meters, they have this crystal oscillator operating above the incoming frequency so that you subtract the 5 megahertz from it, and it produces either 3.5 or 7.0. There's no crystal mixing on 20, and on 15 and 10, the frequencies are added to the VFO. So to get on 20 meters, on 15 meters, you take the VFO plus the crystal oscillator and you mix that with the incoming to get 15 meters or 21 megahertz. So a 12 megahertz crystal with a 5 megahertz VFO gets you about 17. And then I'm sorry, you take the 12 megahertz plus the 9, and then that gets you, with the 5 megahertz, gets you into the 15 meter band. So in the Ten-Tec publication, they show that. Now the thing that's interesting is, because of sideband inversion, they can use a single BFO crystal to essentially come out with the right frequencies for all the bands because of the sideband inversion. And since the LO is operating above the incoming frequency on 40 and 15, there's a sideband inversion. And since it's not operating above on 20 meters and above, there's no sideband inversion, so the single crystal will serve as the BFO. So I had a problem because this little counter here will actually read the real frequencies, and it has an offset. You can plug an offset in there. The problem is you have to toggle the offset. The offset has to be subtractive in one case and additive in the other. And the only way you can do that is some little switches behind there to let you do it. So I was looking for another way in which I could make this work. And so the way in which I made it work was to read the VFO frequency, and in the case of 15 meters, in the case of, let's say, 20 meters and 40 meters, I just take the signal frequency like 7, and in this case it's 7.147. And if it's on 20 meters, it would be 14.147. However, on 75 meters, because that's at 3.5, what I would do is just add that as being like 6. So that'd be 3.647. And if it would read 247, I'd add 2 to that, and it'd be 3747. But on 20 meters and on 40 meters, since the band is operating at in the right range, you just make that added. Just put a note of 7 or a 14 there, or a 21 or a 28. So the thing that is kind of interesting about this is that the VFO is really pretty stable. Actually, I can read, it's reading to hundreds, but you can read the tens, and you see that less 10-digit flicker. So you got no flickering here once you set it. So what I'm going to do is I'm going to mount this unit in this space right here, and this way it'll take up the where normally we had the dial cord and string, which are completely trashed. and essentially turn this into a digital display. So this is Pete here, N6QW, showing the little SandJet display, and I got the green because I thought that looked pretty cool. Anyway, Pete off here. Just a little showing here how the dial moves and follows. Kind of nice. I think I paid $9 for this. Oh, I did have to put something more than a 5 megahertz offset. I had to account for the BFO frequency, so the offset is about 5, so it's subtracted from the BFO plus about 1.1, which is the BFO. So this is actually reading pretty accurate, the accurate transmitted frequency, instead of just reading the BFO. So the offset includes the subtracting 5 plus the BFO frequency, so it's like 5.00011. Pretty good. A little technology. $9 will fix this radio. So again, this is just to put a 7 in front of that. It's 715, 714. Now the one thing that doesn't end up right is you're going to have to do some mental gymnastics when you put the opposite sideband, because it'll work for the normal sidebands on 80, 40, 20, 15, and 10. But if you reverse the sidebands, like for instance on 40 meters, if you want to do 40 meter FT8, you'll get a different reading than normally 7074. But if it's because it's moved to upper sideband, and there's not an easy way to put the offsets in there to do that. I mean, electronically it would have been nice if they had some kind of a pin brought out on the back of this thing. You just ground the pin or unground the pin and either make it a plus or minus offset. So anyway, Pete here. This has the CW filter in it too. Has the RIT on CW. Pretty cool. Technology. Not a lot of money. Less than $100. I got a very nice transceiver here. You know what you're doing. You can really capitalize on some of these basket case rigs. N6QW here. Noontime net on 7.204. Look at that. I got the right offset.